Hello, in this lecture I will answer two questions. In the first question we find out the size of this angle ABC. This is equal to x. We have to find out the value of x, angle x. The second question we find out the length of this line segment AD is equal to x. So we have to find out the length of x. So let's start with the first question. In the drawing we have for the other ABCD, you know that BC equals to BA equals to AD. In addition, you know that this is again BAD. This is equals to 80 degrees inside. This is angle ADC. This is also equals to 80 degrees inside. And again, our task is to find out the size of this angle ABC is equal to x. We have to find out the size of angle x. So, first of all, we will join points B and D together by a straight line. By joining points B and D, we get the triangle ABD. This is triangle ABD. It is given us the question that side AB equals to side AD. Those two sides are equal to each other in their lengths. We have the rule that says that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So in triangle ABD, in front of those two equal sides we have those two angles that must be also equal to each other in their sizes. So if we define the size of this angle as alpha, then the size of this angle must be equal to alpha according to the rule that I mentioned. You also know that the sum of the angles in any triangle is equal to 180 degrees. So the sum of the angles in triangle ABD is equal to 180 degrees. This is to say alpha plus alpha to alpha plus 80 degrees in total must be equal to 180 degrees. In triangle ABD, the sum of the angles must be equal to 180 degrees. Only to the rule that the sum of the angles in any triangle is equal to 180 degrees. So 2 alpha plus 80 degrees in total must be equal to 180 degrees. Here we subtract 80 degrees from this equation. And we get that 2 alpha equals to 180 degrees minus 80 degrees is 100 degrees. 2 alpha equals to 100 degrees. Here we will divide this equation by 2. We can get that the missing angle alpha equals to 100 degrees over 2 is 50 degrees. So if you found out that those two angles are both equal to alpha and each of them is equal to 50 degrees in its size. What is the size of this angle? Angle ADC. Angle ADC equals to 80 degrees minus 50 degrees, that is 30 degrees. This is the big angle minus the small angle, that is actually 30 degrees. It is given us the question that AB equals to BC equals to AD. So define all those two sides that are equal to each other as A. In the next step, we will implement the law of sines. This triangle ABD. Repeat quickly on the law of sines. The law of sines is true in any triangle. This is triangle ABC, that could be any triangle. We know that the length of side AB is C units, side AC equals to B units in its length, and side BC equals to A units in its length. In addition, this angle BAC is equals to capital A degrees in size. This angle ABC is equals to capital D degrees in size. And this angle ACB is equals to capital C degrees in its size. So in this triangle ABC, that could be any triangle. The following equation is true according to the law of sines. A over sinus A equals to B over sinus B equals to C over sinus C. But again, this triangle ABC, the following equation is true. A over sin A equals to B over sinus B equals to C over sinus C. And because of the fact that the law of sines is true in any triangle, we can implement the law of sines. This triangle ABD. According to the law of sines, in triangle ABD, the following equation is true. BD over sinus 80 degrees equals to AB over sinus 50 degrees. Again, according to the law of sines, in triangle ABD, the following equation is true. BD over sinus 80 degrees equals to AB over sinus 50 degrees. So, write it down. BD over sinus 80 degrees equals to AB over sinus 50 degrees. And again, in this triangle ABD, according to the law of sines, the following equation is true. BD over sinus 80 degrees equals to AB over sinus 50 degrees. BD is the missing side, so we leave it as it is. BD over sinus 80 degrees. We'll substitute 80 degrees by 2 times 40 degrees, so it is sinus 2 times 40 degrees. Sinus 40 degrees is sinus 2 times 40 degrees. and it is equals to AB. AB equals to A according to our definition. So we substitute AB by A, or sinus 50 degrees. We substitute 50 degrees by 90 degrees minus 40 degrees. So sinus 50 degrees is equals to sinus 90 degrees minus 40 degrees. So we found out that according to the law of sines, BD over sinus 2 times 40 degrees equals to A over sinus 90 degrees minus 40 degrees. A over sinus 90 degrees minus 40 degrees. We have the trigonometric identity. It says that sinus 2 alpha equals to 2 times sinus alpha cosine alpha. So according to this trigonometric identity, here we have BD or sinus 2 times 40 degrees. According to this trigonometric identity, sinus 2 times 40 degrees will be equal to 2 times sinus 40 degrees times cosine 40 degrees. And it is equals to A. We have another trigonometric identity that sinus 90 degrees minus alpha equals to cosine alpha. Repeat again. The trigonometric identity states that sinus 90 degrees and the second trigonometric identity is sinus 90 degrees minus alpha equals to cosine alpha. So according to this trigonometric identity, we will get that here we have sinus 90 degrees minus 40 degrees is equal to cosine 40 degrees according to this trigonometric identity. So sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So here we have cosine 40 degrees on both sides of the equation, so cosine 40 degrees will get cancelled. After cancel cosine 40 degrees on both sides of the equation, we left with BD over 2 times sinus 40 degrees is equal to A. Again, found out actually that BD over 2 times sinus 40 degrees equals to A. Here we multiply this equation by 2 times sinus 40 degrees. And we get that the missing side BD is equal to 2A times sinus 40 degrees. this is the missing side BD. That is equals to 2a times sinus 40 degrees in its length. Write it down. In the next step, we define this angle, this angle BCD is beta. And we will implement the law of sines in this triangle BCD. In triangle BCD, this is implement the law of sines in this green triangle BCD. According to the law of sines in this triangle BCD, the green triangle BCD, BD over sinus beta equals to BC over sinus 30 degrees. It again in this triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 30 degrees. We just write down found out that BD equals to 2a times sinus 40 degrees. So we solve that BD in this equation by 2a times sinus 40 degrees over sinus beta equals to BC over sinus 30 degrees. Sinus 30 degrees equals to 1/2. So we solve sinus 30 degrees by 1/2. Actually, we know that BC equals to A, so BC equals to A, so we solve BC by A over sinus 30 degrees. Again, sinus 30 degrees is 1/2, so we solve sinus 30 degrees by 1/2. Here we have A on both sides of this equation, so A will get cancelled. After cancel A over A is 1. So 1 over 1/2 is 2. Again, 1 over 1/2 is 2, so this side of the equation we left only with 2. When on the other side of the equation, this side of the equation, we have 2 times sinus 40 degrees over sinus beta equals to 2. Here we multiply this equation by sinus beta, and finally we get that 2 times sinus 40 degrees equals to 2 times sinus beta. Here we will divide this equation by 2. So we get that sinus 40 degrees, this will be equation 1, sinus 40 degrees equals to sinus beta. If sinus 40 degrees equals to sinus beta, it means that beta equals to 40 degrees in its size. The first solution for this equation is beta equals to 40 degrees in its size. We have another trigonometric identity that says that sinus alpha equals to sinus 180 degrees minus alpha. So according to this trigonometric identity, we get that sinus beta according to this trigonometric identity, we get that sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. So she found out that sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. So it is sin 180 degrees minus 40 degrees is 140 degrees. So it is sinus 140 degrees. In total, she found out that sinus 40 degrees equals to sinus 140 degrees. Sinus 40 degrees equals to sinus 140 degrees. Sinus 40 degrees equals to sinus 140 degrees. And also, from this equation, on this number equation, those two sides of the equation are equal to each other. That is to say, sinus beta equals to sinus 140 degrees. So it is now, I should now know that sinus beta equals to sinus 140 degrees. If sinus beta equals to sinus 140 degrees, it means that beta equals to 140 degrees. This is the second solution for beta, but we already found out that beta also could be equal to 40 degrees. So we have two solutions for the value of angle beta, for the size of angle beta. Beta could be either equals to 40 degrees or could be also equal to 140 degrees in size. This is angle beta. From knowing, it is very easy to see that angle beta is definitely greater than 90 degrees. Again, this is angle beta. It is definitely greater than 90 degrees. If angle beta is greater than 90 degrees, then angle beta could never be equal to 40 degrees, that is less than 90 degrees. So we consider this possibility and we take into account only the second solution for angle beta, that is angle beta equals to 140 degrees in its size. So this is angle beta. And note that angle beta equals to 140 degrees in its size. So in the next step, we focus on the green triangle BCD. The sum of the angles in the green triangle BCD must be equal to 180 degrees. So which angles have in this green triangle BCD. 30 degrees plus 140 degrees plus this missing third angle, the angle DBC. In total, the sum of those triangles must be equal to 180 degrees, according to the rule that said that the sum of the angles in any triangle is equal to 180 degrees. 30 degrees plus 140 degrees is 170 degrees, plus the third missing angle, the angle DBC. In total must be equal to 180 degrees. Here we'll subtract 170 degrees from this equation, and we get that the missing angle DBC is equal to 180 degrees minus 170 degrees is 10 degrees. This is the missing angle DBC is equal to 10 degrees in its size. So at the norm, our test is to find out the size of this angle, angle X. It is very easy to see from the moment that angle X equals in total to 50 degrees plus 10 degrees, that is 60 degrees. So actually found out that the angle that we are looking for in this equation, that is actually angle ABC. This is equal to angle X is equal to 60 degrees in size. So we finish with the first question. In the next step, I present to you the second question of this lecture, and we'll solve the second question by using two different methods. Our task in the second question is to find out the length of line segment AD or side AD is equal to X. We have to find out the value of X. So in the drawing we have quadrilateral ABCD. We know that AB equals to BP. We also know that this is short line segment DP. This equals to 1 unit in length. This is line segment PC. This equals to 4 units in length. Again, our task is to find out the length of side AD is equals to X. We have to find out the value of X. So first of all, we will join points B and D together by a straight line. By joining points B and D, we divided quadrilateral ABCD into two parts. The first part is the right triangle ADB, and the second part is the right triangle DBC. So we will implement the Pythagoras theorem on both right triangles, ABD and BCD. So first of all, we will implement the Pythagoras theorem on this upper right triangle, triangle ABD. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here by PT is the version for Pythagoras theorem. So in the right triangle ABD, according to the preparation, BD square, that is the square of the hypotenuse, equals to AD square plus AB square. AD is the nice segment that we're looking for in this question. So BD square equals to AD square plus AB square. And again, in this upper right triangle ABD, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to AD square plus AB square. BD is the missing hypotenuse, so we leave it as it is. It is BD square is equals to AD square. AD equals to x, and therefore AD square equals to x square plus AB square. So, according to the Pythagoras theorem, we found out that this right triangle ABD, BD square equals to x square plus AB square. Likewise, we will implement the Pythagoras theorem on the right lower triangle BDC. Side DC of the right triangle BDC equals to 4 plus 1 is 5. So in this right lower triangle BDC, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to BC square plus DC square. And again, this right lower triangle DBC, according to the Pythagoras theorem, BD square, that is the square of the hypotenuse, equals to BC square plus DC square. BD is the missing hypotenuse, so we leave it as it is. It is BD square equals to BC square. BC is also unknown, so we leave it as it is. It is BC square plus DC square. DC equals to 5, and therefore DC square is 5 squared, that is 25. So in total, according to the Pythagoras theorem in the lower triangle DBC, BD square equals to BC square plus 25. So we have two different equations for BD square. Therefore, we create equation 3 that says that BD square according to equation 1 must be equal to BD square according to equation 2. And BD square according to equation 1 must be equal to BD square according to equation 2. BD square according to equation 1 equals to x squared plus ab squared. And it must be equal to bd squared according to equation 2. Bd squared according to equation 2 equals to bc squared plus 25. So total according to equation 3, we have found out that x squared plus ab squared equals to bc squared plus 25. In the next step, we will implement the Pythagoras theorem on this smaller right triangle PBC. But again, we implement the Pythagoras theorem on this green right triangle PBC. Here by PT is abbreviation for Pythagoras theorem. This green right triangle PBC, according to the Pythagoras theorem, PB squared, that is the square of the hypotenuse, equals to BC squared plus DC squared plus PC squared plus PC squared. And again, according to the Pythagoras theorem, this right triangle DBC, this green triangle PBC, PB squared equals to BC squared plus CP squared. Again, according to the Pythagoras theorem, in the green right triangle PBC, PB squared, that is the square of the hypotenuse, equals to BC squared plus PB squared, that is the square of the hypotenuse, equals to BC squared plus PC squared. According to what is given as the question, know that AB equals to DB. Actually, PA equals to AB. PB equals to AB. PB, the hypotenuse PB of the green right triangle PBC equals to AB according to what is given as the question. Yes. PB equals to AB. So we can substitute PB in the equation 4 by AB because they are equal to each other. So PB squared is AB squared. And it equals to BC squared. BC is the missing side, so we leave it as it is. Plus PC squared. PC is 4, therefore PC squared is 4 squared, it is 16. So in total, according to equation 4, we have found out that AB squared equals to BC squared plus 16. This is according to equation 4, while according to equation 3, we already found out that according to equation 3, we already found out that x squared plus ab squared equals to bc squared plus 25. Again, according to equation 3, we only found out that x squared plus ab squared equals to bc squared plus 25. Okay, now, according to equation 3, we only found out that x squared plus ab squared equals to bc squared plus 25. But we just right now found out that ab squared equals to bc squared plus 16, so we can substitute ab squared in equation 3 by bc squared plus 16. We do it now, we get that according to equation 3, x squared plus ab squared. ab squared according to equation 4 equals to bc squared plus 16. bc squared plus 16 equals to bc squared plus 25. So total according to equation 3, we found out that x squared plus bc squared plus 16 equals to bc squared plus 25. Here we have bc squared on both sides of this equation, so bc squared will get cancelled. After I cancel bc squared, this side of the equation we have x squared plus 16 equals to 25. Here we subtract 16 from this equation, and we get that x squared equals to 25 minus 16 is 9. X squared equals to 9. Here we take a root out of this equation and find that x equals to the square root of 9, that is 3. So line segment side AD is equals to x equals to 3 units in its length. So we finish with the first method. Line segment AD equals to x is equals to 3 units in its length. We finish with the first method. In the next step, I present to you how to find out the length of line segment AD is equals to x according to the second method. In the second method, we will do a construction. That is to say, we will extend this line segment DC by 4 units. Repeat again. We will extend this line segment DC by 4 units. And we define the edge of the extended line segment. This point is point Q. When you extend a straight line by straight line, the result is a straight line. Therefore, PQ is a straight line. So if you focus on the upper side of the straight line PQ at this point C, here the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the areas on one side of a straight line is equal to 180 degrees. So which areas we have at the upper side of the straight line PQ at point C? We have this second, that is right angle, according to what is given in the equation, plus this missing angle. In total, they must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Again, CQ equals to 4 units according to our construction. We extended line segment DC by 4 units. Therefore, CQ equals to 4 according to our construction. Those two right angles ABC and BCQ, they can go into each other according to side angle side rule. So write it down. We have to prove that this is the right line ABC. It is congruent to this adjacent line segment adjacent triangle BCD, adjacent right triangle BCD, according to side angle side rule. So we have to prove that the right triangle ABC congruent to this right triangle BCQ So why those two right triangles can go into each other? First of all, PC equals to CQ equals to 4. PC equals to CQ equals to 4. In addition, those two angles are both right angles and therefore they are equal to each other. So this is again BCP in triangle PBC, and it is equals to this angle. This is actually angle BCQ in triangle BCQ. And again, angle BCP, so actually triangle PBC we have to prove that triangle PBC can go into triangle BCQ. So this is again BCP in the right triangle PBC. This is equal to this angle BCQ in the right triangle BCQ. They are both equal to 90 degrees and therefore they are equal to each other. And finally, this is side BC. This is the common side that belongs to both triangles. So we can write down that BC equals to itself as a common side that belongs to both triangles. So we prove that those two right triangles can go into each other according to side and side rule. The right triangle PBC congruent, this is the side of congruent to the right triangle BCQ according to side angle side rule. That is to say, we actually found out that those two sides, and the angle that is included between those two sides, that is actually right angle, this angle, in this right triangle PBC are corresponding equal to those two sides, and the angle that is included between those two sides in this right triangle BCQ. And therefore those two right triangles can go into each other according to side angle side rule. And from the fact that those two right triangles can go into each other, we derive that those two corresponding sides must be also equal to each other in their lengths. That is to say, side AB equals to side BQ, side PB equals to side BQ. Side PB equal to side BQ. According to the rule that corresponding sides in congruent triangles are equal to each other, those two triangles can go into each other, and therefore the corresponding sides, that is to say BQ and BP, must be also equal to each other in their lengths. So, yeah, PB equals to BQ, and because of the fact that AB also equals to BQ, it means that all those three sides, AB, BQ, and BA, are equal to each other in their lengths. Moving on. AB equals to BQ, and it is also equals to PB. And again, the three sides AB, BQ, and PB are equal to each other in their lengths. In the next step, we will do a construction. That is to say, we draw a circle with the center B. Again, we draw a circle with the center, this center B. The center B and radius AB. Again, the center of this circle is B, and the radius of this circle is AB. And because of the fact that AB equals to PB equals to BQ, the circle must pass for those 3 points A, P, and Q, because they are equal to each other. The rest, that is to say, they are all the area of this circle. Then again, make sure that construct a circle with the center B. The radius of this circle is AB. And because of the fact that AB equals to PB equals to BQ, all those three line segments are the area of this circle. So we define the radius AB is R. This is the radius of the circle equals to R. This is line segment DA. According to what is given in the question, line segment DA is perpendicular to AB. So DA is perpendicular to the radius AB. And because of the fact that DA is perpendicular to the radius AB, it's point A. DA is a tangent to this circle, it's point A. Therefore, DA is a tangent to the circle. From this coming point D, we have tangent DA that is tangent to this circle at point A. Likewise, we have this second TQ. The second TQ cuts the circle 2 points P and Q. So actually, all the requirements of tangent secant theorem are satisfied, and therefore we can implement here tangent secant theorem. So specifically on tangent secant theorem, according to tangent secant theorem, if a tangent and a secant are drawn to a circle from some external point, this is the common external point P. From the common external point P, we have tangent PA, and also we have here secant PC. Then the following equation is true. The square of the tangent length equals to the product of the secant's whole length and its external part. So it is tangent square, the length of the tangent squared times the external part times the whole part. Or PA square equals to PB times PC. Again, the length of the tangent square is PA square, and this equals to the product of the external part of the secant PC, that is actually PB, times the whole part of the secant, that is PC. So total PA square equals to PB times PC. Again, PA square equals to PB times PC. This is according to tangent secant theorem. So we can definitely implement the tangent secant theorem in our drawing. If we focus on this common external point D, from the common external point D, we have tangent DA, that is tangent to this secant point A. Likewise, we have secant DQ, that cuts the secant 2 points P and Q. So all the requirements of tangent secant theorem are satisfied, and therefore I can implement here tangent secant theorem. So the common external point D, according to tangent secant theorem, the following equation is true. dA square, that is the length of the tangent squared, equals to the product of the external parts of secant dq, that is dp, times the whole secant. The whole secant is dq. So it is dp times dq. dA, tangent dA equals to x. X is the 97 that we are looking for in this question. So we solve the dA by x. If dA equals to x, then dA squared equals to x squared equals to dp. dp is the external part of secant dq. And according to what is given as the equation, dp equals to 1. So let's solve dp by 1 times dq. What is the length of the whole length of secant dq? Secant dq equals to 1 plus 4 plus 4, that is 9. Again, secant dq in total equals to 1 plus 4 plus 4, that is 9. So if we found out that x squared equals to 1 times 9, that is 9. X squared equals to 9. Here we take a root out of this equation and find that the length of line segment DA or side DA is equals to x is equals to the square root of 9, that is 3. So in both methods we found out that the length of line segment AD is equals to x is equal to 3 units. So finish with the second question. The next step, as far as the lecture, you start with the repetition of the solution of the first question, and then we repeat on the solution of the second question in both methods. first question, our task is to find out the size of this angle x. It is actually angle ABC. We have to find out the size of angle ABC is equal to x. We have to find out the value of x. So in the drawing, we have quadrilateral ABCD. We know that BA equals to AD equals to BC. BA equals to AD equals to BC. So we defined one side as A, so all the other sides must be also equal to A because they are equal to each other. In addition, those triangles are both equal to 90 degrees in their sizes. This is angle X. We have to find out the size of this angle X. So we know that in front of equal sides in the triangle there are equal angles. Again, in front of equal sides in the triangle there are equal angles. So if we focus on, first of all, we join points B and D together by straight line. By joining points B and D, we created triangle ABD. This is triangle ABD. So dimension in front of those two, in triangle ABD, in front of those two equal sides, we have those two angles that must be also equal to each other and their sizes. According to the rules I mentioned, in triangle ABD, in front of those two sides, we have those two angles that must be also equal to each other and their sizes. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha according to the rule that I mentioned. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So in triangle ABD, alpha plus alpha, that is 2 alpha plus 80 degrees, in total must be equal to 180 degrees. In triangle ABD, 2 alpha plus 80 degrees equals to 180 degrees. Here we subtract 80 degrees from this equation and found out that 2 alpha equals to 180 degrees minus 80 degrees is 100 degrees. 2 alpha equals to 100 degrees. Here we divide this equation by 2 and found out that the missing angle alpha equals to 100 degrees over 2 is 50 degrees. So those two angles are both equal to alpha, and therefore each of them is equal to 50 degrees in its size. So in the next step, implemented the law of sines, this triangle ABD. Let's wait quickly on the law of sines. The law of sines is true in any triangle. This is triangle ABC that could be any triangle. The left of side AB is C units, side AC equals to B units in itself, side BC equals to A units in itself. Likewise, this is again BAC equals to capital A degrees in size. This is again ABC is equals to capital D degrees in size, and this is again ACB is equals to capital C degrees in size. So in this triangle ABC that could be any triangle, according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C. Again, A over sinus A equals to B over sinus B equals to C over sinus C. Because of the fact that the law of sines is true for any triangle, we can implement the law of sines in this triangle ABD. So, in this triangle ABD, according to the law of sines, BD over sinus 80 degrees equals to AB over sinus 30 degrees. But again, this triangle ABD, according to the law of sines, BD over sinus 80 degrees equals to AB over sinus 50 degrees. We substitute 80 degrees by 2 times 40 degrees, so sinus 80 degrees is sinus 2 times 40 degrees, and we substitute 50 degrees by 90 degrees minus 40 degrees. We found out that BD over sinus 2 times 40 degrees, and we substitute AB by A. We find AB equals to BC equals to AD equals to A. So substitute BA by A. BA equals to A, and sinus 50 degrees is sinus 90 degrees minus 40 degrees. And in the other side of the equation, we have dB over sinus 30 degrees, that is dB over sinus 2 times 40 degrees. We have the trigonometric identity that said that sinus 2 alpha equals to 2 times sinus alpha cosine alpha. And therefore, according to this trigonometric identity, we will get that sinus 2 times 40 degrees equals to 2 times 40 degrees equals to 2 times sinus 40 degrees times cosine 40 degrees. Likewise, we have another trigonometric identity that said that sinus 90 degrees minus alpha equals to cosine alpha. According to this trigonometric identity, sinus 90 degrees minus 40 degrees equals to cosine 40 degrees. So in total, we have found out that BD over 2 times sinus 40 degrees cosine 40 degrees equals to 2 times cosine 40 degrees. Here we have cosine 40 degrees on both sides of this equation, so cosine 40 degrees we get cancelled. After I cancel cosine 40 degrees, this side of the equation we left only with dB over 2 times sin 40 degrees, while on the other side of the equation we left only with A. So in total, we found out that BD over 2 times sin 40 degrees equals to A. Here we multiply this equation by 2 times sin 40 degrees and finally found out that BD equals to 2 times A times sin 40 degrees. In the next step, we implemented the law of sines in this triangle, green triangle BCD. According to the law of sines, in this triangle BCD, but first of all, we define this angle BCD as beta. So according to the law of sines, this green triangle BCD, BD over sinus beta equals to BC over sinus 40 degrees. And again, this green triangle BCD, according to the law of sines, BD over sinus beta equals to BC over sinus 40 degrees. We just right now found out that BD equals to 2 times A times sinus 40 degrees. So substitute BD by 2 times A times sinus 40 degrees over sinus beta equals to BC. BC equals to A according to our definition. So substitute BC by A over sinus 40 degrees. Sinus 40 degrees is 1/2. Here we have A on both sides of this equation, so A will get cancelled. After cancelled A over A is 1, so this side of the equation we left only with 1 over 1/2. 1 over 1/2 is 2. Well, on the other side of the equation we have 2 times sinus 40 degrees over sinus beta. So we should found out that 2 times sinus 40 degrees over sinus beta equals to 2. Here we multiply this equation by sinus beta and we found out that 2 times sinus 40 degrees equals to 2 times sinus beta. So here we have 2 on both sides of this equation, so 2 will get cancelled. So cancel 2. We found out that sinus 40 degrees equals to sinus beta. If sinus 40 degrees equals to sinus beta, it means that beta equals to 40 degrees in its size. But we have another solution for beta. Why? Because we have a trigonometric identity that says that sinus alpha equals to sinus 180 degrees minus alpha. So according to this trigonometric identity, we get that sinus 40 degrees equals to sinus 180 degrees minus 40 degrees. 180 degrees minus 40 degrees is 140 degrees. So in total, we should find out that sinus 40 degrees equals to sinus 140 degrees. So we can write here that sinus 40 degrees equals to sinus 140 degrees. Okay? And from this equation, we will derive that sinus beta equals to sinus 140 degrees. Again, from this equation, those two sides of the equation are equal to each other. That is to say, sinus beta equals to sinus 140 degrees. And again, I should find out that according to equation 1, sinus beta equals to sinus 140 degrees. If sinus beta equals to sinus 140 degrees, it means that beta equals to 140 degrees. So we have two solutions for the value of beta. Beta could be equals to 40 degrees, or it could be equal also to 140 degrees. But because of the fact that from the drawing it is very easy to see that angle beta is definitely greater than 90 degrees. Again, angle beta is definitely greater than 90 degrees, and therefore angle beta could never be equal to 40 degrees, that is less than 90 degrees. So we cancel the first solution, and we left only with the second solution for beta, that is beta equals to 140 degrees in its size. This is again beta is equals to 140 degrees in its size. So in the green triangle BCD, the sum of the angles must be equal to 180 degrees. That is to say, 30 degrees plus 140 degrees plus this missing angle, this option angle DBC total must be equal to 180 degrees. Again, angle DBC, the sum of the angles must be equal to 180 degrees. That is to say 30 degrees plus 140 degrees plus the missing angle DBC total must be equal to 180 degrees. 30 degrees plus 140 degrees is 170 degrees, plus the missing angle DBC total must be equal to 180 degrees. Here we subtracted 170 degrees from this equation, and find out that 180 degrees plus 170 degrees is 10 degrees. So the missing angle DBC equals to 10 degrees in size. This is the missing angle DBC is equal to 10 degrees in size. Our task is to find out the size of this angle ABC is equal to x. So in total, angle ABC equals to 50 degrees plus 10 degrees, that is 60 degrees. Angle ABC equals to 10 degrees plus 50 degrees, that is 60 degrees. So the size of angle ABC, that is the angle that you're looking for, is also equals to x, is equals to 60 degrees in its size. So finish with the first question. In the next step, I'll get on the solution of the second question on both methods. Our task in the second question is to find out the length of side AD is equal to x. We have to find out the value of x. So in the drawing we have quadrilateral ABCD. Those triangles are both right angles. We also know that AB equals to BD. And again, our task is to find out the length of side AD is equal to x. We have to find out the value of x. So in the drawing we have quadrilateral ABCD. Those two angles are both right angles. In addition, we know that AB equals to BP, DP equals to 1, PC equals to 4. Again, our task was to find out the length of side AD is equal to x. We have to find out the value of x. So first of all, we join points B and D together by a straight line. By joining points B and D, we created those two right triangles. The upper right triangle ADB and the lower right triangle BDC. So in the next step, we implemented the Pythagoras theorem on both those two right triangles. The upper right triangle ABD and the lower right triangle BDC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle ABD, BD squared, that is the square of the hypotenuse, equals to AD squared plus AB squared. Again, in the right triangle ABD, the upper right triangle ABD, according to the Pythagoras theorem, BD squared, that is the square of the hypotenuse, equals to AD squared plus AB squared. BD is the missing hypotenuse, so we leave this as it is. And this is equals to AB squared plus AD squared. AD is x, therefore AD squared is x squared. So we shall now know that according to equation 1, BD squared equals to x squared, BD squared equals to x squared plus AB squared. Likewise, we implemented the Pythagoras theorem on the right lower triangle BDC. According to the Pythagoras theorem, in the right lower triangle BDC, BD squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. And again, the right lower triangle BDC, according to the Pythagoras theorem, BD squared, that is the square of the hypotenuse, equals to BC squared plus DC squared. BD is the missing hypotenuse, so it is BD squared equals to BC squared. BC is also unknown, so it is so it is BC squared plus DC squared. DC total equals to 4 plus 1, that is 5. DC equals to 5, therefore DC squared is 5 squared, that is 25. So total, according to equation 2, we should find out that BD squared equals to BC squared plus 25. So we have two different equations for BD squared. So we created equation 3 that said that BD squared according to equation 1 must be equal to BD squared according to equation 2. BD squared, again, BD square according to equation 1 equals to BD square according to equation 2. BD square according to equation 1 equals to x square plus AB square. And it must be equal to BD square according to equation 2. BD square according to equation 2 equals to BC square plus 25. So total according to equation 3, we found out that x square plus AB square equals to BC square plus 25. In the next step, we implemented the Pythagoras theorem on this green triangle, the green right triangle PBC. According to the Pythagoras theorem, in this green right triangle PBC, PB squared, that is the square of the hypotenuse, equals to PC square plus CP square. Repeat again, the green right triangle PCP, according to the Pythagoras theorem, PB squared, that is the square of the hypotenuse, equals to BC square plus PC square. PB is the missing hypotenuse, so it is PB square equals to BC square plus PC square plus CP square. PC is also unknown, so it is PB square equals to BC square plus CP square. CP is 4, therefore CP square is 4 squared, that is 16. So total according to equation 4, we should find out that AB square equals to BC square plus 16. Well, according to equation 3, we only found out that x square plus AB square equals to BC square plus 25. So we can substitute AB square in this equation 3 by BC square plus 16 from this equation 4. We did it. And we found out that according to equation 3, x square equals to AB square. And AB square is BC square plus 16. And is equals to BC square plus 25. Here we have BC square on both sides of this equation 3, so BC square will get cancelled. After we cancel BC square on the side of this equation 3, we left only x square plus 16. While on the other side of the equation, we left only 25. So in total, we found out that x square plus 16 equals to 25. Here we subtract the 16 from this equation, and we found out that x square equals to 25 plus 16 is 9. Here we took out of this equation, and we found out that x equals to the square root of 9, that is 3. So we found out that the length of this side AD is equals to x is equal to 3 units. We finish with the first method. The next step, I repeat on the solution. According to the second method, we find out that length of right side AD is equal to x in a different way. So in the second method, we did a construction. That is to say, we extended 97DC by 4 units. Again, we extended 97DC by 4 units. And we defined the extended 97DC, the edge of the extended 97DC is Q. This point is Q. And when you extend a straight line by straight line, the result is a straight line. So DQ is also a straight line. If you focus on the upper side of the straight line DQ at point C, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line DQ at point C? We have this angle that is 90 degrees according to what is given in the equation. Plus this missing angle, the total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in size. The next step, we join points B and Q together by side line. This way we created the right triangle BCQ. So in the next step, we prove that those two right triangles can go into each other according to side angle side rule. So those two right triangles can go into each other. First of all, AC equals to CQ equals to 4. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, side BC is a common side that belongs to both triangles, so side BC equals to itself is a common side that belongs to both triangles. So if you found out that those two triangles can go into each other according to side angle side rule. That is to say, we found out that those two sides and the angle that is included between those two sides in triangle PBC corresponding equal to those two sides and the angle that is included between those two sides. This right triangle BCQ, and therefore those two triangles can go into each other according to side angle side rule. And again, if I remember that triangle PBC congruent, this is the side congruent to the triangle BCQ according to side angle side rule. from the fact that those two point targets congruent to each other, we will have that their corresponding sides must be also equal to each other in the length. That is to say, BP equals to BQ. According to the rule that corresponding sides and congruent targets are equal to each other. Those two targets congruent to each other, therefore their corresponding sides must be also equal to each other in the length. That is to say, BP equals to BQ. Again, BP equals to BQ. And because of the fact that PB equals to BQ and AB equals to BP, it means that all those three sides AB, BP, and BQ are equal to each other. All the three sides AB, BQ, and PB are equal to each other. In the next step, we did a construction. That is to say, we draw a circle with center B and radius BA. So around point B, we draw a circle with center B and radius BA. And therefore, the circle must pass for points A, P, and Q, because BA equals to BP equals to BQ. They are both the area of the circle is equals to 1, and therefore the circle must pass for those 3 points A, P, and Q. And in the moment we have, this is line 7DA. It is perpendicular to the radius AQ and to the radius AB. Line 7DA is perpendicular to the radius AB, therefore line 7DA is a tangent to this circle at point A. And again, because of the fact that line 7DA is perpendicular to the radius AB, it means that PA is a tangent to the circle at point A. Likewise, we have this secant DQ. Secant DQ cuts the circle at 2 points P and Q. So the external part of secant DQ is DP, and the length of all secant is DQ. So all the requirements of tangent secant theorem are satisfied, and therefore we can implement here tangent secant theorem. So quickly on tangent secant theorem. According to tangent secant theorem, if a tangent and the secant are drawn to a circle from the same external point, point P, here we have from the common external point P, we have tangent PA, that is tangent to this circle at point A. Likewise, we have secant PC, that cuts the circle at 2 points B and C. The external part of secant PC is PB. So, in this moment, the following equation is called the square of the tangent length, that is to say PA square, equals to the product of the external part of secant PC, that is PB, times the whole length of this secant, that is PC. Or PA square equals to PB times PC. Again, PA square equals to PB times PC. The length of the tangent squared equals to the product of the external part of the secant times the whole the length of the whole secant. Or PA square equals to PB square times PC. Again, PA square equals to PB times PC. We can definitely implement the tangent secant theorem in our drawing, because we have tangent DA, this is tangent to this circle at point A. We have secant DQ, the external part of secant DQ is DP, and the whole length of this secant is DQ. So all the requirements of tangent secant theorem are satisfied, and therefore we can implement here tangent secant theorem. According to the tangent secant theorem, if we focus on the common sum point D, the following equation is true. That dA squared equals to dP times dQ. Again, dA squared equals to dP times dQ. And again, if we found out that according to focus on point D, the common sum point D, according to tangent secant theorem, the following equation is true. That dA squared, the left of the tangent squared, equals to dP times dQ. dP is the external part of the secant dQ, and dQ is the length of all these seconds. Again, dA squared equals to dP times dQ. dA is x, therefore dA squared is x squared, and it's equals to dP. dP is 1. The external part of secant dQ is dP, and is equals to 1, times the length of this secant. In total, it is 1 plus 4 plus 1, that is 9. So if we found out that dP is 1, dQ, secant dQ in total equals to 9, so x squared equals to 1 times 9, that is 9. X squared equals to 9, here we took out all the zero equation, and finally found out that dA is equal to x is equal to the square root of 9, that is 3. But again, found out that the length of 978 is equals to x is 3 units. So in both methods, we found out that the length of 978 equals to x is equal to 3 units. Okay, thank you very much.